This is Algebra 2, Lesson 7.5, Projectile Motion. So we've talked about quadratic equations in different formats. Vertex form helps us see where the vertex is. Factored form helps us find the roots. And now we're going to use general form to help us figure out what happens when we launch stuff off. The way that we would represent these in general form, y equals, or f of x equals, depending on what notation we're using, ax squared plus bx plus c. A always refers to gravity's pull, and we're going to use different values for gravity depending on what unit of measure we're using. So if we are using meters, that's always going to be negative 4.9. Negative because gravity is pulling us down towards the earth. It's actually half of acceleration due to gravity. If we are using feet, that number would be negative 16. The acceleration due to gravity in feet is 32 feet per second squared, so we're going to use half that, negative 16. It would be different numbers besides if we were talking about inches or yards or miles, and it would be different still if we were on a different planet because, you know, Earth has different gravity than Mars or the moon or anything like that. But I'm going to stick with just those two values for all of these exercises. The b term is referring to the initial velocity. So if we were to drop an item, gravity is still going to pull it down, so it's still going to have acceleration due to gravity, but its initial velocity would be 0 because it's just dropping. If we were to throw something or to launch something like a rocket, it's going to have a higher initial velocity. And then the c term is referring to the initial height of our launch. So if we were going to drop an item off of a building, it would be the height of the building. If we were going to launch a rocket, it would be the height that the rocket launches from, and so on. So most of our launches that we're going to be talking about start at a certain height. We launch them up into the air, but then gravity takes over and pulls them back down. So we still have that parabolic shape to our launch. The way that we would calculate how long it takes to achieve maximum height is the formula negative b divided by 2 times a. And then the maximum height can be calculated by substituting that value. I'm going to call that value h. By substituting that value for h into the y equals equation. And we'll look at what that all means when we get to our example. So we have a model rocket blasting off and its engine shutting down when it is 25 meters above the ground. Its velocity at that time is 50 meters per second. Write an equation to model the rocket's projectile motion. The first thing we need is gravity. Because we're talking about meters, we're going to utilize the negative 4.9 for our a. That's gravity's pull. X squared goes with the a term. Plus, we need the initial velocity next. Initial velocity is 50 meters per second, so that's 50x. And finally, the height at which that velocity occurs is 25 meters, so that is my c term. So we're subbing our three values into our general form equation. The next question, when does the rocket reach its maximum height? So I'm going to use this, I'm going to put equals k right here. I'm going to use this time to max height formula to figure out how long it takes. So to calculate h, that is going to be negative b divided by 2 times negative 4.9. Negative b divided by 2 times a. And we get 5.1 seconds. So this rocket takes 5.1 seconds to reach its maximum height. And what is the maximum height? We're going to substitute 5.1 in for the x's of our original equation. So that's negative 4.9, 5.1 squared plus 50 times 5.1 plus 25. That looks good. And I got 152.551. I'm going to round it to 152.6. So, I labeled these H and K because those would be the values then that would go into our vertex form equation. I don't think that's on here. It's not. But if you remember vertex form from the first page of the packet, and I think we talked about it again on 7.3, we could sub those values into our vertex form equation now, and then that would show us the same information. But I'm going to keep going on to the next question. How high is the rocket at 8 seconds? Again, we're going to just substitute 8 into the x of the equation. So that'll be negative 4.9 times 8 squared plus 50 times 8 plus 25. So same one here. I think maybe I can do this. So 8, and then we'll go over here, and we'll make that an 8 as well. So after 8 seconds, the rocket is 111 meters above the ground. Evaluate h of 14 and explain the real-world meaning. So we're going to substitute 14 into this equation now. And then the real-world meaning of that would be how high is the rocket at 14 seconds? Let me erase some of these extra things that keep popping up. Okay. So if I substitute 14 into my equation, I end up with a negative 235. And that doesn't really mean the rocket is going to burrow underground. It just means at 14 seconds, it's already reached the ground and probably stopped there. And that would be a value that's outside the domain of our problem. Wow. Can't let that one slide. There we go. When does the rocket reach the ground? So that one will require us to use the quadratic formula and solve this equation. So I have my A, my B, and my C. My equation's kind of up higher, but my A and my B and my C are right here. I'm going to use the quadratic formula from the last lesson. We're going to go x equals negative b plus or minus the square root of b squared minus 4ac over 2a. When the rocket reaches the ground is at what time, at what x value is the equation equal to 0, because the ground is height 0. So we're going to put that beast into the calculator. If you're using your order of operations, you could piece by piece this, but since I want to use the whole thing in one big expression, I'm going to use parentheses to isolate my numerator. Squared minus 4 times negative 4.9 times 25. I need to close my parentheses to signify the end of my square root, and then close them a second time to signify the end of the numerator. And I'm just going to go negative 9.8 because I know 2 times negative 4.9. So I have negative 0.477 for my plus answer, and too far. For my minus answer, I have 10.68. So the negative answer is actually outside the domain of my problem. The positive answer, 10.68, shows when the rocket reaches the ground. And if I wanted to solve this equation when it's equal to 60, I'm going to write it out. That's negative 4.9 x squared plus 50x plus 25 equals 60. I have to subtract 60 from each side to get my new C term. That's going to be negative 45. So I got my A, my B, and my C. The only change that I'm really making from this last one is the C term right here is now negative 45. I'm not going to write out the whole equation again. I'm going to just utilize my calculator. I'm going to change my C term. Where is it? And I'm going to make that say negative 45. And that is my minus answer. And I'm also going to do my plus answer. And I get basically 1. So that is saying the rocket is 60 meters above the ground at 1 second and at 9.2 seconds. And finally, we're going to graph this and label everything we have figured out. So we have our rocket blasting off and crash landing. It blasted off at 25 meters. Now this is not drawn to scale, but it took approximately 5.1 seconds for it to reach its maximum height, and that maximum height was 155 meters. It reached the ground at 10.1 seconds, I think. Oh, 10.68. It was right there. 10.68 seconds. And at 8 seconds, 8 would be right about there, we know that the measurement here was 111.4, I think it was. If we kind of like went straight there, we'd have the 8 seconds there. We have the 5.1 seconds here, leads to the 155 right there. And then the last piece of information was when was the rocket at 60 meters. This is really not drawn to scale, but 60 is going to be in here approximately, and that would lead to a time right here at 1 second, but also a time right here at 9.2 seconds. So I can't really fit this on there and make it look that neat, but hopefully that is clear how each of these values landed on our graph. That is it for my notes. Good luck on the exercises, and please let me know if you have any questions.